Okay guys, today we'll be doing 3.4 Advanced Power Rule. Let's go forward. Okay, first thing. Oh, sorry, I'm just trying to get my pen to work. Here we go. Okay, using the prior knowledge, so what we did yesterday, the power rule, take a stab at the instantaneous rate of change of the function. Remember, instantaneous rate of change, meaning derivative. So, y prime. Okay, well, yesterday what we were doing is we were taking this exponent right here, we're bringing it down, and so what do you think we would do here? We would multiply them. So it'd be 28 now. Okay. Now we would still do, remember, right after you bring it down, you subtract 1 from the exponent, making this 3. And that would be the derivative of that. Okay, let's write this out in a mathematical notation. You know what? How about I'll just write it out for y'all. So if we start out with something, we're starting out with some sort of constant in the front times x to the n. So the derivative would be, this n would come down, multiply with the c, so it'd be c times n, and then it would be x to the n minus 1. And that would be your next rule, Rule 3, the power rule with constants. And I got it on the next thing here. The constant multiple rule. And there is the form that we just wrote it out in. Okay, let's do a couple examples here, which we already did this one. It was bring down the 4, multiply the 7. So 28, x to the third. Okay, this one right here. This one's a little more difficult. Remember, we write these, we need to write it with a power. So 4x to the half. Okay, now we can take the derivative because we've written it with a power. So we bring down the half to multiply with a 4. And that's basically division. 4 divided by 2 is 2. X to the, and then we're going to subtract 1 from the exponent here. 1 minus 2 is negative 1. So it'd be negative 1 over 2. And all we need to do is make sure that this exponent is positive, so you can circle it here. And you can move it to the bottom, so it'd be 2 over x to the half, which is the same as 2 over square root of x. Okay guys, let's go to the next PowerPoint here. Okay, find the equation for the slope of the tangent line of each of the following functions. Okay, notice all these key words I'm keep throwing out here that are telling you to take the derivative. Find the equation for the slope of a tangent line. Slope of a tangent line of each of the following functions. Okay, so what we need to do is we need to rewrite this as 3x to the negative 2. Remember, you got to write it on the numerator. So now we can take the derivative. That's going to be negative 2 times 3, which is going to be negative 6. X. Subtract 1 from the exponent. Negative 3. Can't leave the negative exponent, so you circle what you need to move. We're going to move it to the bottom of the fraction. So negative 6 over x to the third. Okay, that's an equation for the slope of the tangent line. Yeah, it finds the slope anywhere we want. Okay, let's do this next one here. If you notice here, there's 2 x's. It's trying to confuse you. Let's rewrite it so it's all in exponents here. So we got 6x to the, remember the exponent here is 1, over x to the, and remember, this is going to be a fractioned exponent. Remember, there's like a 2 here. And this is going to be 5 divided by 2 for our exponent. Okay. So we want to make this to be one variable. That way we can take the derivative. So I'll put an equals sign here. I am not taking the derivative yet. I'm just rewriting this still because we want it on the top. So it's going to be 6x to the, okay, now how are we going to figure this out? Remember, when you're dividing, you subtract the exponents. So we can write this as 2 over 2, so we have a common denominator. Okay, that's the same as 1. 2 minus 5 is going to be the same as negative 3 over 2. Okay, this right here is that rewritten. Now, since I have it rewritten where I can take the derivative, I can begin taking the derivative. So I'm going to bring that down here to multiply with the 6. Now, here's where people get confused, because you're multiplying a fraction with 6. Just think of 6 as a fraction as well, 6 over 1. Okay, so the numerators multiply, so 6 times negative 3, it's going to be negative 18 over the 1 times 2. 2. X to the, what's my new power? So remember, negative 3 minus 2, negative 5 over 2. And you know what? I just realized this. Throughout yesterday's lessons, I was writing this all on the numerator. So notice this portion right here is supposed to be on the numerator with the negative 18. Okay, now we can simplify all this. So you know what? First thing I'm going to do is I'm going to divide this negative 18 and 2. It's going to be negative 9 x to the negative 5 over 2. Okay, at this point, this thing has a negative exponent. I can't leave negative exponents, so I'm going to move it to the bottom. So my answer is going to be negative 9 over x to the 5 over 2. Okay, well, I also don't want to leave fractions in the exponent, so my derivative in its final form would look like this: negative 9 over square root. Remember that square root's coming from the division by 2. That's how we unsquare rooted this one, right? X to the 5th power. Okay, that's the derivative of that thing. This finds the slope of this graph anywhere we want. Let's go on. Let's go forward. Okay, the fourth rule we're going to learn is the sum and difference rule. This is a very simple rule, okay? It's kind of similar to what we've been doing. How do you think you do these problems below? Well, you think of each one of these terms, so this term, and this term, as their own derivative. Okay, so we're going to be taking the derivative of this one, and don't even look at the other ones yet. Just take the derivative of this one. That's going to be 2x. Okay, we're done with that one. Let's go over here. Take the derivative of 5x. It's going to be 5. Now take the derivative of 3. Remember your constant rule. It's a constant number, so the graph of negative 3 would just look like 1, 2, 3. And the slope of it is always 0. So the derivative of any constant is 0. So there is the derivative of this. You just do it term by term. So let's come over here and do this longer one. So bring the 4 down, subtract 1, so it'll be 4x to the 3rd. Okay, multiply this by this. Now, people get confused. If you're getting confused because there's a fraction over there, make this a fraction. 3 over 1. Okay, 3 times 2 is going to be 6. I'm going to minus 6 over 3 times 1 is 3. X to the new exponent is going to be 2. And that goes on the numerator, yeah, with the 6. Plus, bring down the 2, so it'd be 4x to the 1st power. I don't need to write it. Plus, derivative of x is just 1. The derivative of negative 6 is 0. Okay, there's the derivative. I mean, I can rewrite this a little bit better, but that's it. So 4x cubed minus 2x squared plus 4x plus 1. And that is an equation to find the slope anywhere we want for this graph. Tells me the slope. Okay, that's the sum and difference rule. Okay, here's some of the more difficult ones you might run into with sum and difference. This right here, it's not written in terms yet. This squared, you guys know what to do when you see that squared. Let's rewrite it. That means x minus 4 times x minus 4. Yeah, you can multiply this out. So this is the same as x squared minus 4x minus 4x plus 16. Okay, and this can be rewritten as x squared, combine the like terms, negative 8x plus 16. Okay, now we can take the derivative. It is written in terms now. Before, there was this 2 here ruining that idea of it being written in terms. That's squared. So now we can take the derivative. That's supposed to be a y prime. Here, I'll just put another one so it doesn't look weird. Okay, let's take the derivative term by term. Take the derivative of this term, 2x. Take the derivative of that term, minus 8. Take the derivative of this, 0. Okay, that's the derivative. That finds the slope of that function anywhere you want. Okay, here's a more difficult one. This is probably the one where you're going to want to focus on what I'm doing here. We need to distribute this in order to write it in terms where we can take the derivative. So, y equals this times that. Now, let's first rewrite this. 2x to the half, I don't want anyone to get confused. 5x plus 3x to the, remember this is the bottom of the fraction when we write it, so 4 over 3. Now we can distribute, okay? So, y equals, remember when you multiply you add the exponents. So this is the same as 1, which is 2 over 2. 1½ plus 1, a half plus 1 is the same as 1½ plus 2 over 2, which is the same as 3 over 2. So we're going to have 2x to the 3 over 2 plus, we get a half plus that. Now the coefficients we're just going to multiply. 2 times 3, 6. X to the new exponent is going to be a half plus 4/3. Okay, I'll do that right over here. A half plus 4/3. Okay, I need a common denominator. That means I need to multiply this one by 3 over 3, which is going to make it 3 over 6. Plus, I'm going to multiply this one by 2 over 2, which is going to make it 8 over 6. Now we got a common denominator. We can add them. That's going to be 11 on top and 6 on bottom. So there we go. That's my new exponent here, 11 over 6. Now it's written in terms. I can take the derivative. I've rewritten it fully. Okay, I bring this down. I multiply that exponent with this. Again, if you're confused, just put that over 1. Now you have fraction times a fraction. 2 times 3 is 6 over 1 times 2 is 2. X to the new power is going to be 3½ minus 1, which is 3 minus 2 is 1 over 2. Remember, this thing is on top. It's on the numerator with the 6. Don't get that confused. If you want, you can just extend that line down. Okay, plus, I need to bring this over here. 6 times, and then here you put it over 1. So 6 times 11 is going to be 66 over 6 times 1 is going to be 6. Then x to the, we subtract 1. That means 11 minus 6 is going to be 5 over 6. And then let's rewrite this because we can simplify all this stuff here. It's going to be 3. 6 divided by 2 is 3. And this can be rewritten as a square root of x plus 66 divided by 6 is 11. X to the, now we're going to rewrite this. Remember, the division is the root. So you have a 6th root of x to the 5th power. There we go. That's the derivative. That equation right there will find the slope of this anywhere you want. That's everything for today, guys.